So let's talk about the notion of congruent polygons. Congruent polygons, it says right here, two polygons are congruent if and only if all of their corresponding parts are congruent. By corresponding parts, of course, we're referring to their angles and their sides. Now, the more sides your polygon has, the more pairs of corresponding congruent parts they're going to have. Here I have two triangles, so I'm going to have 6 pair of congruent corresponding sides. I'm going to have 3 pair of corresponding congruent angles, and I'm going to have 3 pair of corresponding congruent sides. If you have an octagon, you're then going to have 16 different pairs. 8 pairs of sides, 8 pairs of angles. Okay? So looking at my diagram, they are already marked. Angle A is congruent to angle H, B is congruent to J, C is congruent to angle K. Same with the sides. Okay? AB is congruent to HJ, BC is congruent to JK, and AC is congruent to HK. Now notice the order of the letters. It's very important when we're talking about congruent polygons, okay? Because when I get down to my congruence statement, okay, which you're going to have to learn how to write, you're going to have to write your own congruence statement, you're going to name a polygon, right? You're going to have 2 polygons. The first one you name, you can name it in any order you want. I don't care what order those letters are on. This one happens to be triangle ABC. Notice the colors that they use here, blue, red, green. When you name your first polygon, it does not matter the order of the letters. The second one, the order matters. It has to be with the corresponding congruent parts, okay? A is my first letter. Look at A was congruent to H, so H has to be my first letter. Then A went to B. B corresponds to angle J, so since B is my second letter, J has to be my second letter. And of course, lastly, C was congruent to K, so since C is the last letter, K has to be the last letter. That way, if we're talking about congruent polygons and I don't have a diagram to look at, I know from this statement what the corresponding congruent parts are. Okay? Let's look at an example here. It says, write a congruent statement for the triangles and identify all the pairs of congruent corresponding parts. So, first off, congruent statement. Let's start there. Triangle. Pick these letters in any order you want. Okay? I'm going to say CAB. Is congruent to triangle. Now, look at the other diagram. C here, see it has the 2 arcs in here? What angle has 2 arcs in the other triangle? That's angle H. So C corresponds to H. So H, angle A is the right angle, angle F is the right angle. So A corresponds to F. And lastly, of course, B then has to correspond to angle G. Triangle CAB is congruent to triangle HFG. Now, if I don't have a diagram and I have to list all the corresponding congruent parts, here, let's do a little trick here. Ready? I'm going to take the picture away. Why? Because I don't need it for the next part. Identify all the corresponding congruent parts. Angle C is congruent to first letter, angle H. Angle A is congruent to angle F. Second letter. And last, angle B is congruent to angle G. So this is why when I name the second polygon, the order is very, very important. That way when I look at the names and I don't have a picture, I know what the corresponding congruent parts are. Now, we did the angles, let's do the sides. Remember, when you do sides, 2 letters. Side CA, first letter, second letter, is congruent to side HF. Second letter, third letter is congruent to second letter, third letter. The third side, doesn't matter how you name it. So if I did CB, first letter, last letter, CB is congruent to first letter, last letter, HG. So again, this is why the names are very important when I'm doing corresponding congruent parts. If I look at this, I should be able to get all of these even without a picture. Okay? Next example. In a diagram, QRST is congruent to triangle WXYZ. Find the value of x. So first off, where's the x's at? Well, here's an x. But with that x, there's a y. So I'm probably going to have to get x first before I can get y. Where else is there an x? Right here. This x is part of angle W. So now go back to your name. Angle W is the first letter. So the first letter over here is angle Q. So W corresponds to angle Q. This is why the names are important, because sometimes these shapes are flipped, turned, and rotated, so you don't know which ones are the correct ones, or which ones correspond to them. So this is congruent to this. So 5x plus 5 is equal to 65. Solve for x. X equals 12. Now I can solve for y. Because I know x is 12, so I'm going to put a 12 in here for this x. So wx is actually y minus 12 now. Well, wx, again, look at the letters. wx, first two letters, corresponds to qr. qr is 6 inches. So y minus 12 equals 6. Solve for y. Y equals 18. Again, very important that this is why the naming of the shapes is important. The first one doesn't matter. The second one has to be in the corresponding congruent parts. Now, triangles. We've already discussed that all the angles of a triangle inside add to 180. This here says if I have two triangles, and angle C and angle K are congruent, and angle B and angle J are congruent, the third angles theorem says, well then that means the third angles also have to be congruent, even if they're not marked. Because all triangles add to 180. Okay? So third angles theorem. If two angles are congruent to two angles of another triangle, the third angles have to be congruent. Let's put that to practice right here. So, I have two triangles, there's a lot of triangles here, but I'm looking at this triangle and this triangle. I see this angle is marked congruent to this triangle, this angle. Now this is very important. When they're doing problems, they're not going to mark your vertical angles congruent, because we should know by the vertical angles theorem, all vertical angles are congruent. So I know that this angle is congruent to this angle. Notice I have two pair of congruent angles in these triangles. So since these angles are congruent and these angles are congruent, that means S has to be congruent to V. So if I want to find angle V, all I have to do is find angle S. Remember, all angles add to 180. So to get angle S, I'm going to do 180 minus the sum of the other two. Okay, 66 plus 44 is 110. 180 minus 110. 70 degrees is the measure of angle S. Angle S is congruent to angle V, so angle V is also 70 degrees. Okay? Now, there's three properties here listed at the bottom. These are properties we've already seen. We saw them of equality, we saw them of congruent segments, we saw them of congruent angles. Now we're looking at of congruent polygons. The names are the same, the properties are the same. It's just how many letters we're using, folks. Reflexive property. Triangle ABC is congruent to triangle ABC. It's congruent to itself. Reflection, kind of like your reflection in a mirror. Symmetric. If triangle ABC is congruent to triangle EFG, then EFG is congruent to triangle ABC. Turn it around. Symmetric. Turn it around. That's it. Okay? Transitive property. If ABC is congruent to EFG and EFG is congruent to JKL, take out the one that's in the middle, that's in both of them. ABC is congruent to triangle JKL. Those are your reflexive, symmetric, and transitive properties of congruent polygons.